Very good afternoon, students. How are you all doing? Are you all doing good? Okay. Today we are going to start with this first chapter in chemistry, that is volume 1, first chapter we are going to start today. I hope you all listened to this last class audio, that is the introduction about this topic, and I hope you all know me very well. I am Ms. Subhashini. I'll be handling chemistry for you for this academic year. And then I would like to share this: if you are having any textbook, it's well and good, and if not, also you try to get it from your neighbors or from your friends. Try to keep it. We also will share the photos, but still, if you try to get the textbook from your friends or your neighbors, it's well and good. Old textbooks you can get and use it from them. Today we are going to start the first chapter, Metallurgy. The first chapter we have is Metallurgy, and this volume 1, as I told already, we have 7 chapters in volume 1. First 5 chapters will be inorganic chemistry. That is, metallurgy also will come under inorganic chemistry. So we are going to start with this first chapter today. So I hope you all will be having a basic idea about this metallurgy. Yes or no? So you would have studied extraction and purification of metals in your 10th standard. Yes or no? Like extraction of copper, extraction of iron, aluminothermic process, all these are the process where the extraction of metals involved. In periodic classification in your 10th standard you would have studied. So this chapter in your 12th standard you will be exclusively studying how to extract all the types of metals and what are the different steps involved in the purification and extraction of metals. So that is, we will be discussing about the methods of concentration of ores and extraction of crude metals, and what are the thermodynamic principles involved in this metallurgical processes, and also we'll be having a Lingam diagram, which is very important, and electrochemical principles of metallurgy and the application of electrochemical principles in extraction of metals, and electrolytic refining, and finally uses. So what does this metallurgy mean? Metallurgy means a science and technology of metals, study of science and technology of metals. We call it as metallurgy. So in nature, only a few metals they will be occurring in native state. Native state means what? They will be occurring in the free state directly, and many other metals will be occurring in the combined state only, like in the forms of their oxides, sulfides and silicates. So definitely we need some extraction techniques to purify them, because we need them only in pure state for many applications. So if you take aluminium, iron and all, it is having a very important role in our daily life. So we need them in their purified form, but they exist only in the combined state in nature. So we need to purify them. So we have to follow few techniques and few methods to purify them, and also it should be eco-friendly, which means it should give more yield, wastage should be lesser. So the production must be, the product which we obtained should be more in amount than the wastage, and also it should not create any environmental issues to the any environmental issues to the environment also. So it should be practiced very well, and it should be extracted in such a way. So that is what we are going to discuss in this unit. First is occurrence of metal. How does a metal occur in nature? So generally we all know the property of a metal. Metals are shiny, malleable, and they are also found in different nature as compounds with different properties. So they will be having different chemical reactivity. So if you see metals having lesser amount of chemical reactivity, like copper, silver, gold and platinum, they occur in significant amount as native elements. Only significant amount is available as native, that is in free state. If you see reactive metals, so reactive means they will quickly react with water or any gas, any other metal. Like alkali metal means, if you see, all these alkali metals are very very reactive, and they are also existing in combined state. So they are extracted using certain metallurgical processes only. So we will see how does this metals will be occurring on the form in the nature. So they will be existing in the nature as minerals and ores. So what are called minerals? Very very important to mark. and 2 marks or 3 marks is repeated question. Difference between mineral and ore. Listen here. A naturally occurring substance obtained by mining which contains the metal in free state or in the form of compounds like oxides and sulfides, we call it as minerals. So in most of the minerals, the metal of interest is present only in small amount. So minerals la metals எப்படி தான் present ஆயிருக்கும், they'll be present only in the small amount, and some of them they contain reasonable percentage of metal, which means quite a good amount of a metal. Like for example, if you see this iron is present around in 800 minerals. Iron is present in 800 minerals, but some of them are hematite, magnetite, and containing high percentage of iron. They are commonly used for this extraction of iron. Such minerals that contains higher percentage of metals from which it can be extracted conveniently and economically are called ores. So now can you guess what is the difference between mineral and ore? Minerals means they will be having only a small amount of metal of our interest will be present, whereas ores, if you see, high percentage of metal will be present in ores. So this is a very common difference between this, very important difference between mineral and ore, and hence all the minerals all the ores are minerals, but not all minerals are not ores. So ella ores may we can say it as minerals, but we can't say all the minerals as ores. Now if you consider bauxite and china clay, they both are the minerals of aluminium, but however if you see this aluminium commercially they can be extracted from bauxite itself. So while extraction from china clay is not a profitable one, so if you see mineral, here is bauxite is ore of an aluminium, while china clay is not at all a mineral of an aluminium. And if you see, this extraction process involves 3 steps. First is concentration of the ore. Concentration means we have to remove all the major impurities. If you are mining it from under earth or underground, it will be coming along with many other impurities, especially silica, which is sand. So we have to concentrate them. We have to bring it into a lesser amount. That is concentration of ore. And extraction of crude metal is removing the next stage of impurities. We bring the crude metal, and then we have to refining it is, while extraction of crude metal will be having only 50 to 60% of metal, remaining 40 to 30% of impurity will be there. So to remove that we have to refine it, only then we will get 99% of pure metal. So these are the 3 steps. And if you see in this table, aluminium, the ores of aluminium are bauxite, diaspore and kaolinite. Zinc, if you see, zinc blende, calamine and zincite. Iron, if you see, hematite, magnetite, siderite, iron pyrite and limonite. Lead, we have galena, anglesite and cerussite. And then tin, if you see, cassiterite. Copper pyrite, copper glans, cuprite, malachite and azurite. Silver, argentite, ruby silver, horn silver, stephanite and prostite. So all these are the different ores of different metals, and it is very important, along with the formula, and the different names could be asked in 2 marks or in the match the following or in the objectives also. First we are going to the concentration of ore. So what is done in the concentration process? So what could be done in the concentration? In concentration we are going to remove all the non-metallic impurities and rocky materials. So non-metallic impurities, rocky material, the kallu, mannu, siliceous matter, the sand, everything will be collectively we call it as gangue. So all this will be removed in the first step. The preliminary step is when the metallurgical process is the removal of all these impurities. The first step what they will do, they will remove this gangue. What is gangue? Non-metallic impurities, rocky minerals and siliceous matter, we call it as a gangue. And then this removal we call it as in concentration of ore. It increases the concentration of metal of our interest or its compound in the ore, and several methods are available to do this. So we have gravity separation or hydraulic wash. So what do we do in this gravity separation or hydraulic wash is that in this method the ores having high specific gravity, which means more density is separated from the gangue. So higher higher specific gravity means more density jaasti and they will go down. So gang, they will be having lower specific gravity, so they will run simply, they will be washed away along with the water. So the one which is having higher specific gravity will be separated from the lower specific gravity. Here the lower specific gravity one is gang. Okay, so which will be simply washed away with the running water. And now ore is crushed to a finely powdered form and treated with rapidly flowing current of water. So what we have to do, the ore we have to crush them finely, and then or fast rapidly flowing water we have to show that ore, and we have to pass the have to make the ores to pass through that rapidly running water. So what will happen during this process? The lighter gang particles are washed away by the running water. So now the lighter particles, that is the gang particles, will be washed away. This method is generally applied to concentrate the native or such as gold and oxide or such as hematite. So here we can see what are the very common ores it is used in this method in gravity separation, like hematite, tinstone. Next is froth flotation, which is very important. Again, it could be asked in 5 marks. Along with the diagram you have to do when it is asked. This method is commonly used to concentrate sulfide ores such as galena. So froth flotation means it is generally with galena only. So galena and zinc blend. So these are the two common sulfide ores which is applicable to use this froth flotation. So in this method, the metallic ore particles which are preferentially wetted by oil can be separated from gang. So very important, froth flotation can be used only for the sulfide ores. Here we have to wet all the ores with the oil to get separated from the gang. You all know what is meant by gang. What is gang? All the siliceous material, rocky impurities, rocky materials, and then non-metallic impurities, we call it as a gang. So to remove that gang particles, we have to mix it with the oil. So here also first we have to crush the ore which is suspended in water and mixed with a frothing agent. So here the frothing agent means nora varradha da nama frothing அப்படினு சொல்றோம். And frothing agent here we use pine oil or eucalyptus oil we have to use, and a small quantity of sodium ethyl xanthate. So all these are very very important. It could be asked and give reasoning questions also. So sodium ethyl xanthate, which acts as a collector, is added and a froth is generated. So what will happen? And now this turbine will run. You can see a fan like a structure here that will run now, which will create a froth there. Okay, we have to blow air also. Air supply also must be given for the production of this froth. Okay, and after adding the sodium xanthate, a froth is generated by blowing air through this mixture. So we have to blow air to generate this froth, and the collector molecules attach to the ore particle and make them water repellent. So what will happen? Then the collector edukku use பண்றாங்க, we added no sodium xanthate. It will attach with the ore particles. ore particles ஓட அது ஒட்டிக்கிச்சு அப்படின்னா நம்ம ஆட் பண்ணியிருக்கிறோம்ல தண்ணியோட அது கலந்து வராது. ஸோ இம்ப்யூரிட்டிஸ் மட்டும்தான் தண்ணியோட வெளியே வரும். ஆஸ் a result, ore particles wetted by the oil rise to the surface. So what will happen? All the gang and impurities will be left behind at the bottom of the container itself. Now the sodium xanthate will cover all the main important ore particles, which will bring them up along with the froth. Okay, and the froth is skimmed off and dried to recover the concentrated ore. Can you see it is skimmed off means it is separated on the other side of the container, and then it is dried, and the gang particles that are preferentially wetted by water will be settled at the bottom. So we made the gang particles to be mixed with water, so they will be at the bottom, and these ore particles are ores, important mineral ores, will be along with the sodium xanthate will come up along with the froth, which will be collected separately. Once that is done, it will be dried and then it will be removed. When a sulfide ore of a metal of our interest contain other metal sulfides as impurities, depressing agents. So இப்போ நம்ம மெட்டல் நம்ம ஓரோடையே சேர்ந்து இப்போ 2-3 சல்ஃபைட் ஓர்ஸ் ப்ரெசென்ட் ஆயிருந்துச்சு அப்படின்னா we have to add the depressing agent. இப்போ ஒரே ஓர் மினரல் தான், ஒரே ஒரு ஓர் தான் இருக்குது, பட் அந்த ஓர்லேயே டிஃப்ரெண்ட் டைப்ஸ் ஆஃப் சல்ஃபைட்ஸ் இருக்குது. ஜிங்க் சல்ஃபைடும் இருக்குது, அயன் சல்ஃபைடும் இருக்குது அப்படின்னா எனக்கு தேவையானது ஜிங்க் சல்ஃபைட் மட்டும் எனக்கு தேவை, எனக்கு அயன் சல்ஃபைட் வேண்டாம் அப்படின்னா we have to use this depressing agent. Like sodium cyanide and sodium carbonate are used selectively to prevent other metal sulfides coming to the froth. அப்போ நமக்கு தேவையில்லாதது வரவிடாமல் தடுக்கிறதுக்கு இந்த டிப்ரெஸிங் ஏஜென்ட்னா, டிப்ரெஸிங்னா என்னது, டாமினேட் பண்ணிடும். இட் வில் push the one which we know need to the bottom, that will leave behind whatever we are needed. For example, when impurities such as zinc blend is present in galena, sodium cyanide is added. So for example, இப்போ நம்மளோட ஓரில் zinc blendம் இருக்குது, galena-வும் இருக்குது அப்படின்னா இப்போ sodium cyanide ஆட் பண்ணும்பொழுது it will depress the zinc blend. That is ZnS வந்து டிப்ரெஸ் பண்ணிவிட்டு இட் வில் ஃபார்ம் அ காம்ப்ளெக்ஸ். எப்படி அதை டிப்ரெஸ் பண்ணோம், நம்ம ஆட் பண்ண சோடியம் சைனைட் வந்து ஜிங்க் பிளெண்ட் ZnSோட சேர்ந்து ஒரு காம்ப்ளெக்ஸ் ஃபார்ம் பண்ணிடுச்சுன்னா அது என்னவாயிடும், டிப்ரெஸ் ஆகிடும். நம்ம கேலனாவை மட்டும் பிரித்து எடுத்துக்கலாம். இஸ் இட் கிளியர்?